Okay guys, let's do another proof. I also intend to do this one from both sides just to show to you that with a proof you can start from any side you like. So when I look at this proof, just from the first side, in my opinion, the right hand side is easier because that is a compound angle identity. I know the formula. This is a double. So maybe let me start with the easier one, then before we can go to the one that needs a little bit of thinking out of the box. So if I were to be a student to solve this one, I will start with the right hand side. So the right hand side is 2 the sine of a minus b into a minus b divided by sine 2b. So that numerator sine a minus b is a compound angle identity, which is simplified as sine a cos b minus sine b cos a. For level 4 students, that's formula number 10 on your formula sheet. Then denominator is a double angle identity, which is 2 sine b cos b. And for level 4 students, it's formula number 12. So here you see that the 2 will immediately eliminate itself. Then I'm left with sine a cos b minus sine b cos a divided by sine b cos b. So here sine b cos b is now like the LCD. So I can give it to the first and to the second term because LCD, that's the lowest common denominator, belongs to everyone at the numerator. So I will share it and say cos sine a cos b, I will divide by sine b cos b minus sine b cos a divided by sine b cos b. So you see the LCD, some people call it LCM, belongs to everyone at the numerator. So that is how you put it. So from here you see that cos b will take care of cos b here, and here sine b will take care of sine b. Then we'll be left with sine a over sine b minus cos a over cos b, and that corresponds exactly to our left hand side. So if I were to be a student and I'm doing that proof, I would prefer to start from right to left. So that was just to demystify the fact that students must not always think that they should start from left to right. So now let's see if I were to say I want to start from the right, from the left, will I survive? So I want to prove, so I'm starting sine A over sine B minus cos A over cos B. So to handle this, we immediately see that these are two fractions. When you're adding or subtracting two fractions, the first thing should be your LCD. That should be our very first thing to do. We look for the LCD. So the LCD, as I've said, some people also call it LCM, means these two numbers are different, you just multiply them out. So I get sine B cos B, then I'll take this, divide there, you see sine B will cancel itself, that one multiplies. So I get sine A cos B followed by the negative sign, if this goes here, cos B will eliminate itself, then I get sine B cos A. So if you can look at that numerator very well, and you're familiar with compound angles, if you look at the arrangement, you see that it's a mixture of sine and cos are the numerator. So that is what I will tell my level 4 student, that is formula number 10 on their formula sheet, because the arrangement there is sine cos. So if you're going to that other side of the formula, it should be sine A minus B. So now I'm working with the left hand side, so I must be looking at the right hand side where I'm going. You see that there is a 2 there, which does not appear there. So what do? You simply introduce that 2 here, but without changing this problem. The only thing you can do without changing the problem is to use that 2 that you see there to create 1 by writing 2 divided by 2. then you multiply into our fraction. So if you do this, you now see that the 2 that we made in front of that has appeared without really creating any harm. So we get 2 sine bracket a minus b. So the numerator is sorted. Denominator is 2 sine a, 2 sine b, 2 sine b cos b. And that is our double angle identity, which for our level 4 students is formula number 12 if you are looking at it from the right hand side. So on the left, it will just be sine 2b. And we started with the left, so we ended with the right hand side. We started with the left, and we have ended with the right hand side. So you see that a proof can be done from any side. So it's just for you to look at the 2 methods that I've done for each of these proofs. Then you decide which one is easier for you, you stick with it. But the advice is that each time you look at the proof, look at the side that is easier, especially if you are using a formula sheet, pick the side that has formulas on your formula sheet that you can easily copy and start with. So let's now look at something else now. We want to prove, so we want to simplify without using a calculator. So this is not a proof, so you don't know where you're supposed to end. So you just need to take your time, look at the formulas, you put them, you start moving. So if I analyze this, that is a compound angle identity, which for my level 4 students, it will be formula number 11 on their formula sheet. They've given you the left hand side, so you will get cos 45. If I'm simplifying it, it will be cos 45 cos theta, plus the negative goes with the positive, plus sine 45 sine theta, then divided by cos 45 cos theta, then minus tan. I can leave that one like that for now. Then I will see that this is the LCT for that. So I will get cos 45 cos theta divided by cos 45 cos theta. So this is the LCT or LCM. I'll give it here, I'll give it there, plus sine 45 sine theta divided by cos 45 cos theta, then minus tan theta. So this one will take care of this will take care of this. Means the first term is a 1, then sine over cos is a tan, so this is plus tan 45, then multiplied by tan theta, then minus tan theta. So that is it. So this becomes 1 plus. So if you are familiar with special angles, you will know that tan 45 is just a 1. If you're familiar with that, or another thing we will say is that sine 45 is 2 over 2, cos 45 is 2 over 2, so you see this one actually creates a 1. So this is just 1 there, then plus tan theta minus tan theta, so you see that simplifies, and your final answer is 1. So that's how simplification of trig functions works. So when you are simplifying, you are like reducing the trigonometric identity till you get something that is small. So guys, thanks a lot. I hope I've helped you on proofs and simplification.